All right, thanks, Ron. All right. So first of all, we'll meet Trellix. I think Ron did a great intro, so we can speed through that, and then we'll talk about the different types of AI, where the safety comes in. For this OWASP top 10, and then we'll look at some different use cases. So I'm Martin Holsey, CTO for Cloud and AI at Trellix. As Ron mentioned, Trellix is the merger between McAfee Enterprise and FireEye. So if you're familiar with either or both of those companies, it's all of that plus all the things we've been doing over the last couple of years since the merger. All right. So let's get right into it. What are the different types of AI? I like to level set with this because we've been hearing about AI for, a whole decade now, and we need to understand, okay, now that we're hearing about AI constantly all day, every day, what are we talking about? So originally there's the machine learning, which is given a data stream, a bunch of ones and twos. You can ask, is a 10 normal? And it'll say no, it's anomaly detection. You could say what comes next? Well, the pattern recognition would say it's probably a one or a two. So this is where you get anomaly detection. You get image recognition, so that if you think of ones and twos as pixels in a picture, that's facial recognition. It also, goes towards self-driving cars and even, figuring out what the lanes are on a road. So all the driving assist stuff, that's all machine learning like that. And then, of course, predictive analytics like stock predictions, weather forecasts, et cetera. So what are the strengths, weaknesses, and opportunities for machine learning? So if you look at the strengths, it's knowable. It's pretty easy to understand the algorithms because they're fairly straightforward for the most part, and they're generally tend to be robust. The weaknesses, they rely on having very high quality data. Any kind of problem with labeling is going to make for garbage in, garbage out. The opportunities, you can combine them, you can use them in new places. There's still a ton of research going on in machine learning. It's not going anywhere. We're talking a lot about generative AI lately, but machine learning is still very important. Some of the threats on it are the output quality, some misuse, of course, and things like that. All right, so the main thing we want to know about though is generative AI. And this is similar, it builds on machine learning. The neural networks, all those kinds of things actually come out of machine learning. But what's different in generative AI is really how that's applied. So it's a transformer and it's predicting the next token. So we saw prediction in machine learning, but this is a far more complicated version. And as per that, and you need a PhD to really get into a lot of this. But the upshot is that instead of thinking in terms of numbers, it's going to think in terms of words or tokens, and it can sort of edit as it goes. So it may think, okay, I'll do quick brown bird, but then it'll back up and say, no, I want to do quick red fox. And so that's one of the biggest differences is that it knows how to revise what it's working on as it does it. And that's what gives it the ability to create content that's far beyond just simple predictions. So here's three very important differences. Machine learning is often trained on customer data. Now, it doesn't have to be. You can train it on some data and then release it. But a lot of the security stuff is trained on customer data because you're looking for spikes and anomalies on a per customer basis. Meanwhile, generative AI is trained on essentially the internet or just general knowledge. And it's pre-trained. So it's essentially the same for all when you initially ask questions. And there's fine tuning, and we'll get into that. But as it starts, it's pre-trained. Second biggest difference is that while machine learning requires that sanitized data or things that are perfect, Gen AI is really good at fuzzy matching and figuring out the gist of whatever you've given it, which is a huge advantage. And then lastly, here, Gen AI can produce code and content, which machine learning itself generally isn't used for, other than the fact that it's sort of a building block for Gen AI. All right, so there's different ways of running Gen AI. You can use the public service, like you all know about ChatGPT or the Anthropic API that's out there. You can run it on Amazon Bedrock or Google Vertex or Microsoft's version of OpenAI. Of course, Gemini from Google just launched last week, so there's another version there as well. Or you can run it on-prem. And this is something that's becoming more and more common as we look at LLMs that can run on a device. So, for instance, Llama, a very well-known open source LLM, can actually run on a Mac M2 or an M3, depending on the size of it. So this is becoming sort of a new frontier for running your own smaller models, in addition to things that are maybe hosted in the cloud or even as an API. So fine tuning is when you take a pre-trained model and you add a little bit of your own data to it, essentially. And so when you run it, you're running against the fine-tuned model. You're not running against the foundational model, even though it's sort of a layer on top. What's nice about it is, unlike machine learning, you can generally do it on a lot fewer examples. Machine learning will generally take, thousands or hundreds of thousands or even millions of specific data points in order to retrain the model. Fine tuning can be done in just a few thousand examples. So it's a much more, human oriented versus machine oriented kind of fine tuning. But it can be fairly expensive, and the operations of it can be fairly annoying to go through. Prompt engineering is a new field, and this is a big deal as we look at it. In particular, this is a great way to illustrate the difference between something like machine learning that's fairly simple and the complex version of machine learning that has become generative AI. Gen AI was trained on the internet, and people express emotions on the internet. And as such, a very strange thing is that you can actually evoke emotion from the AI and get better responses. And so this paper goes into some of the actual differences that they get performatively by append or prepending things like take a deep breath and work on this step by step. This is becoming more and more common as people work with things like ChatGPT, in their daily lives. Figuring out ways to better express yourself with the LLM becomes more and more important. So it's a completely new frontier. It's very interesting from a computer science perspective because we've never interacted with machines like this before. And it goes even further. There's entire categories of different types of essentially motivation that you can give to these LLMs. And I won't go through the whole thing, but this is a expanding body of work. All right, so what do LLMs understand? From a security perspective, they can be really good. They can understand data formats very well. So things like CSV, they can pick out things that are malicious, and they don't need to be told what's malicious ahead of time or trained on that. They can understand based on little bits of text in here, like knowing what a password spray is, tells them that this IP address is actually malicious. All right, so what are the overall use cases for Gen AI? You can create code. You can do multimodal analysis. This is a big deal right now on things like ChatGPT and Anthropic, where you can upload a picture and it'll describe things. You can basically upload a screenshot of Wordle and it'll solve your Wordle for you, which is kind of funny. It's really an expanding area right now. And of course, you can chain things together and get different technical documentation. All right, so what can't we do? What are the limitations? It can't send a lot of data to it. Unlike machine learning, this is more, piecemeal. We can't ask it a ton of questions because it is fairly expensive to run. In general, you can think of one question being sent as the equivalent of an hour of CPU time. If you're thinking about cloud costs, that's pretty close for a lot of things. We can't always trust its answers. As I'm sure you're aware, it can hallucinate and give invalid responses pretty frequently. So you have to check your work each time. And it's not always quick. You don't notice ahead of time, but it may take many minutes. And sometimes we don't know exactly why it gave an answer. You can't really go back and figure out exactly why it said what it said. All right, so that kind of rounds out the SWOT. It's really good at understanding and creating things, but it does have mistakes and cost associated with it. And there are a lot of opportunities and threats. They're both basically unlimited. So we'll dive into the threats right now on the safety part of it. All right, so this is a really good example of if you kind of go too early by launching your own application backed by an LLM, what can go wrong from at least a customer's perspective. So this is an example of a bank putting out a assistant chatbot to help with customer service, which is a great idea. Unfortunately, it's not a great look for a bank when you can convince the AI agent that it actually has a different name. So what if that were actually a different account number or something like that? Now, that may not be the case. Maybe this was perfectly safe, but you wouldn't really know that at the time. So that's something to really watch out for when you're hosting these things. This was an example of the custom GPTs that came out just a few weeks ago. This was launched, in my opinion, in a very insecure way because no one was aware of the safety considerations for putting out these custom GPTs. So in this case, this was basically an escape room where you could convince the GPT to give up some password information that it wasn't supposed to prior. And even worse, no one was aware at the time that you could actually download someone's entire configuration by forking it, as they said, which was supposed to be a feature, but it was actually a huge security risk because it also came with things like API keys attached to it. So this is definitely on the list of what not to do when you're launching. So if you want something a little more formally codified, the OWASP now has their top 10 for LLM applications. I'll go through three of them here, not all of them, but it's a well-defined list of all the things to watch out for when you're building applications that are backed by LLMs. So the first is prompt injection, which is kind of the new SQL injection, and that's the jailbreak that I just talked about. It's one of the most the biggest problems to worry about because there's so many ways to do it and not a great way to defend against it right now. The second is the insecure output handling. So since you can't exactly predict what the output is going to look like, being able to handle that properly is a big deal. So whatever you're putting on the page suddenly becomes really important. And the other one we'll cover here is sensitive information disclosure. So you need to make sure that you're passing through the authorization from the client all the way to the backend data source that you may be, if you're doing retrieval augmented generation, which is basically API calls that go along with the LLM response. So the LLM may be kind of quarterbacking exactly what data it needs, and if it doesn't know exactly who it's acting on behalf of, then it will do something it shouldn't and retrieve information it shouldn't have access to. Then there's the attacker's use. So in the last presentation, you heard perhaps defenders have the advantage. I'm not entirely convinced of that right now. We'll show you the things that we can do as defenders. But I'm particularly worried about the attacker's use of AI because AI is really good at writing code, and attackers use a lot of code. So anytime they can get into an environment, they can more easily understand it and operate more quickly in it. And so that is a big threat. Basically, if you think of an attacker that used to have to go out and learn something new or contract someone on the dark web, they can now do that on their own much more quickly. So they're much more dangerous, and you have to be aware of that. The MITRE has their Atlas attack framework here, which covers LLM application security. And they even have a list of real world case studies here from supply chain attacks where things like PyTorch, which is one of the most important AI libraries, was actually hacked. And so they had a big supply chain attack on that, to things like getting around existing security infrastructure all the way to actually using it to write bad code. All right, I'll quickly cover where we come in on how to secure against AI. So we have an XDR, and you can put a lot of things into it, including things like Amazon events, our own platform events, or pretty much any event you can think of. You dump it all into the detection factory, and you get our unicorns and rainbows, the magic of detection that comes out on the other side. This often looks like chaining things together. So being able to connect dots all the way from maybe email for using our email platform through a directory, whether that's Microsoft or Google or wherever that's coming from, to be able to figure out what the user was, and then trace that all the way through the actions that they've taken, perhaps all the way into CloudTrail, and being able to map someone that got a phishing message to all the different actions that they took in a given Amazon environment or all the Amazon environments. And this is particularly helpful as we're trying to figure out how to secure an application with an LLM backend. Bedrock is particularly good if you enable the logging of sending not only the input, but also the output into CloudWatch. We integrate natively with CloudWatch, and so now your security team can get direct access to everything that's flowing through your AI applications, which is a huge step towards getting some observability and the ability to detect malicious things happening in your AI-based applications. We also at Trellix have just added a new preview for our detection that uses generative AI. So this is how we're enabling defenders to actually start to get more work done. Most of the alerts that come through something like an XDR or a SIM don't get seen because they're low or informational, and it's not, you don't have time in the day to get through all of them. Something like 90%. We can actually use AI to do all that investigation for you and figure out basically which alerts need to be pushed up so that they get noticed by security staff in that top 10% of most critical alerts. We do this by using our investigative tips automatically. And so we run those. We say, okay, we got an alert. Maybe it's a CloudTrail or GuardDuty alert came through. And then we're going to go back and figure out all the things that affected it. And so this might be any other access to that role, might be any phishing emails that came in, it might be service accounts that are created. Now, these are just sort of general searches that we do, but we summarize all that information for that specific alert, and then we give it to an AI running on Bedrock, and we can actually make some really good determinations about whether or not we should raise that alert so that somebody sees it. And the critical thing here is that this is all happening on your behalf in the background. You don't have to do anything. You don't have to type. You don't have to read. Suddenly, you'll just get higher quality alerts that are showing up, and they're things that you never would have seen. You can also do it manually, and this is what we have started to do automatically. You can basically look at these investigative tips, which for a given CloudTrail event or something like what actions did it take, or what are the other roles that exist for this. And we run all those automatically in the background on your behalf. And then we send something that summarization based on that alert into the AI. And then we can get really good determinations. So here's an example of something coming from Office where the alert was escalated because it noticed that all the other events attached to it actually amounted to password spray attack that was successful. And so the LLM recommended increasing the severity of this alert. So it created a case, attached all the evidence to it, and then set the rating to be high so that it gets noticed. And this is how good it is. It can take a giant pile of probably malicious text and tell you exactly what's going on in it. And this is why it's so good at making these determinations on your behalf in the background, because it can figure out that in this giant pile of what's probably SQL injection, sure enough, it's attacking a specific IP with a reverse shell to do things like create directories and change permissions. And we can use all that to not only create the new case that you're going to notice, but we can also use this to start to build out the orchestration. And so that's our big advantage here as you're trying to, as a defender, use AI to your advantage. We have a ton of data that comes in the first place. We have the investigations that go with them. And that means that we're able to send the right data to the local LLM sitting right next to your data to make a better determination. So this is available today in our preview program. Anybody that's using our XDR can go and enable that and opt in. And interested in any questions that you guys have after. Thank you.